Today in this class we are going to discuss one question of linear programming formulation problem. I am taking this question from the university exam, BPUT university exam, that is exam 24 and 25. This is the quantitative technique question paper of 24-25 year, and this is a linear programming formulation question. This is a 6-mark question asked by the university exam. Let us see how we are going to solve this question. So, need to discuss about the question first. A firm manufactures two types of product A and B and sell them at a profit of rupees 2 on type A and rupees 3 on type B. This is the unit of contribution for type A and type B. Each product is processed in two machines, machine C and machine D. Type A requires 1 minute of processing time in machine C and 2 minutes in machine D. Type B requires 1 minute in each machine C and machine D. Machine C is available for not more than 6 hours 40 minutes. This is the constraint. This is the limitation. And machine D is not available for 10 hours during the working day. Formulate as LPP. So we need to express it in the linear programming formulation or mathematical way of our linear programming. This is the mathematical model, you can say, of linear programming. So how we are going to write? As we all know, that is the first step is we have to take a decision on the decision variables. Means how many number of units of A and how many numbers of unit of B we need to produce to maximize the profit. Because this is a profit case. Profit means it is a maximization case. For as we all know, if 1 unit of A we are selling, then we are making profit of 2, and if we are for product B, we are making a profit of 3. And each product is processed in 2 machines. So first we need to identify the decision variables. Let's assume that x1 units of A and x2 units of B is produced or manufactured. Let us assume x1 unit of A and x2 unit of B is produced or manufactured. So we know XA is produced A. We can write this is A, this is B, this is x1 units, this is x1 unit, and this is x2 units. So always try to make the linear programming into a tabular form, the formulation problem into a table form, because it makes to understand it well. So always try to make it in a table form, the formulation part. So you can easily write the what are the constraints and how we can write the mathematical model form. So we know x1 is our decision variables, x2, x1, x2 are decision variables. And what is the non-negativity constraints? x1, x2 always greater than equal to 0, because we are producing x1 units and x2 units, that cannot be negative or 0. These are called non-negativity variables. And here another one thing, each product is processed in two machines, C and D. This is machine C and machine D. Type A requires 1 minute of processing time in machine C. Type A requires 1 minute processing time in machine C and 2 minutes in machine D. 2 minutes in machine D. Type B requires 1 minute in each machine. Type B requires 1 minute in each machine. Machine C is available for not more than 6 hours 40 minutes. So machine C is available for 6 hours 40 minutes. 6 hours 40 minutes. This is our constraint. Machine CD is available for 10 hours. 10 hours during the available day. Formulate as LPP. So what we can do? We can express this. This is in minute. So if we convert it into minute, then it will be 6 hours means 6 into 6, 60 plus 40 equal to 360 plus 40, which is equal to 400. So we can directly write 400 minute here. We can write 400 minute. 400 minute in minute. This we can write 600 minute. 10 hour equal to 600 minute. So how we are going to write the constraints? Constraints we can write for machine C. Machine C. X1 plus X2 should be less than equal to 400. For machine, because this machine is our constraint, because we cannot use the machine C more than 400 hours and we cannot use machine D more than 600 minutes. Sorry, machine C you cannot use for more than 400 minutes and machine D you cannot use for more than 600 minutes. So how we can write? 2x1 plus x2 is less than equal to 600 and x1, x2, non-negativity constant always greater than 0. And what is our objective function? Objective function is Z maximum, we know, equal to, what is the contribution, unit contribution? Sell them at a profit of 2 on type A and 3 on type B. So 2x1 plus 3x. So this is our objective function subject to the constraint and this is our non-negativity constraint. So we can write it like this. So always try to express the linear programming problem, formulation problem, because it looks like a big one, but when we write it in a table form, then it will reduce to a very convenient way to express it to a mathematical model. So first step is to find the decision variables x1, x2. We have taken as the number of units need to be produced or manufactured. Here machine C is used for 400 minutes and machine D is used for 600 minutes. And what is the profit? Profit is mentioned here. For machine A it is 2 rupees and for machine sorry, for product A it is 2 rupees and product B is 3 rupees. So first you write the constraints, like for machine C, x1, because A is for 1 minute we are doing. So 1 minute is machine, 1 minute, this is for 1 minute. So x1 plus x2 less than equal to 400. Then for machine D the constraint 2x1 plus x2 less than equal to 600. x1, x2 always greater than 0. These are the non-negativity variables. And we have to write the maximization z maximum equal to 2x1 plus 3x2. This is the objective function. So this is the form of linear programming formulation. We need to solve it like this. I hope you understand how we need to solve the linear programming formulation problem. If you like the video, please share with your friends and subscribe the channel. Thank you so much.